Thank you. Hopefully you can all hear me on this microphone, yes? So I just want to start by saying, I think a lot of us have been here since the beginning of this Natural History Conference. And I am thrilled to hear how many people mentioned climate change in their presentations yesterday and this morning. I think it's very clear to all of us that this is a super important issue. So this is a really super quick review, Climate Change 101. We are putting a lot of greenhouse gases in our atmosphere. That is making our atmosphere warm. That is making our ocean warm. And that is making sea level rise. We saw this graph yesterday, so I won't go into it in too much detail. But the point is just that in the Northeast Atlantic, the ocean is warming up substantially, and especially in just the last several years. You heard Janet and I say yesterday, they thought it was going to sort of go up a little and then level off again, and it has not leveled off. So maybe we're sort of entering a new warmer period in the ocean. Precipitation changes. We are expecting maybe a little bit more precipitation, but the really important impact we're expecting is that the precipitation we do get is going to come in really big dramatic events. So we're going to have bigger storms, more intense rain, not so much this drizzly over 3 days kind of thing, but a much greater percentage of our rain is going to come in the heaviest 1% of events. And what that means in New York, for example, if you think about this, this is amazing. Every person in New York State lives in a county that has been impacted by some weather disaster in the last 10 years. And that's not just rain related, that's all weather disasters, tornadoes, floods, hurricanes, et cetera. But essentially, everyone who lives here knows this. Our weather is getting more extreme and more dramatic. And as you can imagine, that has a ton of implications for plants, for animals, and for people. This is a photo from Hurricane Sandy taken down in Mastic Beach. And this is one of those dramatic kind of events that we're going to expect more and more of, especially as the ocean water is getting warmer. That means more energy and greater storms, bigger storms, more dangerous storms. But the impact that I want to talk most about today is sea level rise. In addition to the occasional flooding caused by storms, we're also experiencing flooding because the sea level is rising. The cause of that is a combination of things, a little bit of subsidence on the land or rebound from glaciers leaving. But primarily, it's from two things. It's the thermal expansion of the water in the ocean itself, and then the melting of our polar ice. And with sea level rise comes flooding. And you can see, so if you can see these bar graphs, the orange bars, which you can barely see in most of these places, that's the average number of flood days per year in the 1950s. And then these blue bars are the average number of flood years in the 2010s. So we've had a dramatic increase in flooding, and it's happening all across the country. And another thing I want you to notice about this is that it's happening in some of our biggest, most economically important, and most populous cities. You saw these numbers yesterday. These are the official sea level rise projections for the state of New York. Like all good government agencies, our state adopted official sea level rise projections, but they didn't adopt one. They adopted 7 regions with a matrix of 25 numbers. So pretty much there's something for everyone here. But at this point, they did this several years ago, and already these low and low medium projections, we're sort of ignoring them because we are on a trajectory far worse than that. We have not turned things around in putting greenhouse gases in our atmosphere yet. So we're really looking to the right side from your perspective of this chart. And what we're talking about over the next 80 years is 6 or even 7 feet of sea level rise. And that's vertical feet. So I want you to think, especially on Long Island where the slope of the land is very shallow, 7 vertical feet is a tremendous distance inland from shore. And it's really going to change the shape of Long Island and the shape of all the coastal ecosystems that we all love to spend time in. This is just another figure. So this is the mid-range, a figure by 2100, 21 to 50 inches we should expect. And that's kind of conservative. That's if we really get it together and start to fix our climate change problems. And what this causes is, you heard yesterday called sunny day flooding. You also hear it called nuisance flooding, which is a terrible name for it. If anyone is experiencing this, it's far from a nuisance. The term I like to use is chronic flooding. So this is not occasional flooding from a nor'easter or a hurricane, but this is every spring tide, every neap tide, a couple times a month. This is what it looks like on your street. And there are a lot of places on Long Island where this is happening already, and those places are going to increase and increase and increase. I couldn't hear you, but you can tell me later. No, this is actually Mastic Beach, but Freeport is one of them for sure. So what I want you to think about in this photo is that there are a couple things impacted here. This is your day-to-day life. This is, I keep waders in the back of my car just in case. This is, sometimes I have to park my car 3 blocks away and walk in because I don't want the undercarriage of my car to be in salt water. This is not an easy way to live. And it's not just your house and the people, but it's the roads, which are important not just for the people who live on them, but for the people who have to drive on them to get other places. These are just a couple of examples. This is Mastic Beach, and that's Orient Point over there. These are some of the roads that are in danger of being inundated every 30, 60, and 90 days in those bluish colors, and then during coastal storms in the red and yellow. So this is a lot of roads being impacted on Long Island. And it's homes. And it's not just the street in front of your house, but it's your actual house. So the Union of Concerned Scientists did a great study. They took data from Zillow, that app that you use when you're house hunting, about home prices, and mapped it out with the flood predictions. And the number of homes in New York predicted to be impacted by chronic flooding, and they define that by twice a month, at least every 2 weeks. It's 15,000 homes by the year 2045, and 145,000 homes by 2100. That's a tremendous number of people being impacted. And I'll just draw your attention to this map here showing where the greatest risk and the biggest problems are. You should all recognize that is where we live. And if you're interested, this is a great website. They put together a great mapper from this data. You can zoom in by zip code or by town, and you can get information. So I just popped up Babylon for an example. By 2100, we expect 8,600 homes to be chronically inundated, so basically really difficult to live in. The collective worth of those homes is $156 million, 24,000 people impacted, and it also tells you that it's $3 million toward the property tax base. So this helps you to understand, even if you're not a coastal homeowner, this helps you to understand how it can impact the economy of where you live. And if you look island-wide, this is from the Nature Conservancy's Coastal Resilience Mapper. This is the county line between Suffolk and Nassau. So looking at Suffolk County, all of those blue areas are places where sea level will rise. The lighter blue is it will rise sooner, and the darker blue is it'll take a little bit longer. But it's really going to change the shape of our island. It's going to narrow the island, but along the edges, and in particular out on the forks, it's really going to change the shape of everything. We're not going to have forks anymore. We're going to have 2 little archipelagos sticking out at the end of our island. So you can imagine how that is going to change the entire landscape and all of the habitats. So when we talk about climate change, this is the vocabulary lesson of the day. There's really 2 things we talk about. There's mitigation and adaptation. And these are kind of the 2 actions that need to be taken because our climate is changing. And mitigation is super important. I don't want to spend a lot of time talking about it today. I'll come back to it at the end, though. This is what you can do. This is basically how we prevent these problems. So all the things we do, renewable energy, buy a Prius, all of those kind of things, that's how we mitigate climate change. And we have to do that urgently if we don't want this problem to get much worse than what I've just described. But the fact is, we've already set this course in motion, so we also have to adapt to the changes. We're already seeing a lot of changes, and we will continue to see them even if we do a great job with mitigation. So we also have to prepare to adapt to climate change, and that's what I really want to talk about. Long Islanders are increasingly becoming aware that we have no choice and we have to learn how to adapt. There's a wide range of things we can do to adapt. Some are good for the environment, some are good for people, some are good for both. And what I and the Nature Conservancy, and I think probably most of you, would like to see is a future where both the people and the nature are thriving. So to do that, what we want to do is build a resilient system. So I'm sure you've all heard 1,000 definitions of the word resilience. It means that you're able to handle the changes that we're seeing and still get along just fine, and preferably thrive. And in a coastal system like ours on Long Island, 5 things are needed for that system to be resilient: clean water, dynamic sediment, room to move, the full tidal range, and thriving communities. That's human communities. And I just want to talk about each one very briefly. Clean water is first. I hope that if you live on Long Island, you've been bombarded by the message of clean water. We have a lot of water quality problems on our island. Here's just a little sampling of them. And I don't want to dwell on this image, but to tell you that the blue part of these pie charts is essentially the human pollution factor that is causing all those water quality problems. So the problem is us. The problem is our wastewater. There is a great deal of momentum now happening to clean up that problem, but it needs to continue because it's going to be exacerbated by climate change, and it's going to make it much harder for us to be resilient to all of those changes that we're seeing. Here's one example is clams, but I want to talk about shellfish in general. Shellfish need that clean water. They can help us clean up the water, but it has to be clean enough for them to actually survive in order to do that. So all of those water quality problems that we have are creating algal blooms, which are the wrong kind of food for shellfish, and our shellfish aren't surviving. And this is true for clams, oysters, scallops. Incidentally, climate change is also contributing to something we call ocean acidification. Scientists are really just starting to understand its impacts on shellfish, except that we know it does impact them. It impacts their ability to build their shells. And probably more important, it's impacting their ability for the larval shellfish to settle and really get started. So we're just learning about how those impacts are going to increase as climate change increases. But the combo of the nutrient problems, creating algal blooms, and the acidification is a recipe for disaster for shellfish. And as climate is changing, as sea level rises, first of all, the very coastal homes, their on-site wastewater systems are in direct contact with seawater sometimes. And as sea level rises, so does groundwater. So that's making our already sort of mediocre on-site wastewater treatment far less effective and increasing the eutrophication problems that are making life difficult for shellfish. And it's not just shellfish. Wetlands and seagrasses also are highly impacted by poor water quality. We're going to talk about them again in a minute. The second thing we need for a resilient system is a dynamic shoreline. You heard a great presentation about this yesterday, those of you who are lucky enough to be here, from Kevin McAllister, so I won't go into too much detail about it, except to say that erosion is not a problem to be solved. Erosion is a natural process, a process that we need. If we want to have beaches, if we want to have sand in our system, it has to come from somewhere. Typically, a homeowner's response, or a homeowner's way to adapt to erosion on their property, is to build a wall, or a revetment, or a groin, or something, to prevent that natural dynamic process. And if you look just on the footprint of one property, that seems quite reasonable. But if you can force yourself to kind of zoom out in space a little bit and think about if you make that same decision on every property, pretty soon we have a concrete bathtub that used to be a bay with a lot of critters and marshes and seagrasses, and instead we just have walls. What happens when you build a wall, if you can see in this photo, the area closer to us, this bluff is eroding, but there's a little bit of a beach in front of it. And at low tide, there's a pretty good sandy beach down there. But the further away properties, you can see where they've built walls. And what happens is when you put those hard structures there, the energy from waves and water bounce off of it, and it actually makes the erosion much worse. It will protect what's behind the wall, but only to a certain point. And in front of the wall, you wind up destroying the beach, and then you have nothing. And you don't have that intertidal zone that's so important to so many species. Horseshoe crabs, for example. So hopefully a lot of you know all about horseshoe crabs. They're a very charismatic critter, the dinosaurs of the sea, we call them. They've been around for millions and millions of years. Very important for a lot of testing in our medical community. So they're testing the cleanliness of our equipment and the safety of things they're injecting and putting into your body. They've not figured out a way to manufacture these things. So they're super important to human health. They're also super important to the ecosystem, not just the crabs themselves, but a ton of shorebirds depend on the eggs of these horseshoe crabs to survive their big, long migrations. This one's just a red knot, one of the more important relationships with the horseshoe crabs. But tons and tons of shorebirds depend on this very important food source. And these horseshoe crabs need that sandy beach in order to survive and stick around on Long Island. I would hate to be the society, the generation that ruined millions of years of survival of these critters. Another thing that needs that sandy and intertidal zone is seagrass, highly impacted by water quality, but also needs that sandy substrate in order to grow. So maybe the sand eroded from in front of your house, but the place that it landed created an important substrate for seagrass. So we have to remember that that sand is going somewhere, and it's needed wherever that is. Maybe it's building the beach downstream, but it's super important. And hopefully you can all see this. Wait, I have a pointer. There's a seahorse here. I hope you all know we have seahorses on Long Island, one of our more charismatic critters that we have. And they're highly dependent on seagrass. They hide in the seagrass. They hang on to it. And we've lost most of our seagrass on Long Island already because of our water quality. And what's happening now is the water quality, which is making it difficult for seagrass to undergo photosynthesis, is now combining with warming water, making it even harder for seagrass to survive. And you can also see some little shellfish stuck to that grass. You're far enough away that I could lie to you, but I won't. I do not believe these are scallops on the seagrass in this particular photo, but you often see scallops stuck to seagrass just like that. Scallops are really tightly coupled with seagrass ecosystems. We've lost a lot of our scallops, partly due to fishing and partly due to habitat loss, but they cannot come back because we don't have enough seagrass for them. So lots of important critters really suffering either because of climate change or because of the things that we're doing to try to adapt. Another thing a healthy coastal system needs is room to move. You heard this yesterday. Beaches, sand dunes, wetlands are very resilient on their own. If left to their own devices, they can survive a lot, but they will move around. They won't always be in exactly the same place. So what we need to do is kind of back up and give them some space. So this is just Mastic Beach as an example. These blue areas show you where existing wetlands are. And the green area is what we call the Marsh Migration zone. So that's where wetlands will migrate to as sea level rises. They will build up vertically, and they will migrate inland so that we're always fringed by wetlands. That would be great if we didn't have blocks and blocks and blocks of people and roads and driveways and infrastructure in their way. So as sea level rises, we'll lose a lot of what we currently see as wetlands to open water. But we won't lose the wetlands if we give them some space to back up and get up higher. This is a salt marsh sparrow. I think that we have probably a lot of birders in this room who know more about these guys than I do. A very charismatic salt marsh species. They're adorable. They love to hold on to a couple of different reeds like that. They make a lot of noise. But these guys are so interesting, and they're really tightly tied to salt marshes. It's the only place they live. It's the only place they can eat. And they typically nest in the high marsh. They have very high fidelity to these sites. If their nest is successful, I'm told they will come back to within a meter of where their nest was last year, the following year. If it's not successful, it will still be in the same marsh, but they might try a different spot. So they're very dependent on these wetlands, and not just any wetland. Like the wetland where they grew up is what they're dependent on. So this is really important. One little piece of good news about these guys, though, we've been very concerned about salt marsh sparrows and saying that they're going to be gone from Long Island very soon because of what's happening to our wetlands. But we're starting to see now that they are building nests actually in the low marsh, which we didn't think they could do. So these guys are pretty adaptable, too. They're running out of high marsh habitat. They're kind of making do with a secondary habitat that's not as great. But as long as they can keep their nest up out of the salt water, they're trying it. They're giving it a go in the low marsh. So that's good news for these guys. The fourth thing we need for a resilient coast is the full range of tide. This is super important. What you can see here is a wetland that's flooded. This is not a bad thing. This is what makes a wetland a wetland. This happens a couple times a day. And this is what helps a wetland outcompete all the other plants in the world, and what makes these plants and this ecosystem so special. This is what helps bring the fish in and out. Wetlands are really important nursery habitat for a lot of species that are important to recreational and commercial fishing. Those things are important to the big charismatic stuff like whales and seals and all of those guys. A super important habitat that we're losing very quickly. And if we choke it from the tide, like with a road or with a culvert that's not big enough, it's not going to remain a wetland. But as long as the tide comes in and out, this is the natural native habitat that will grow on Long Island. So this is a property, this is again Mastic Beach, you should recognize the bridge. This is a property that used to have a house and a driveway on it. And when those were removed, we didn't even have to do any restoration. The wetland grew back naturally. And with it, all of the birds and critters that love to be there. So as long as the full range of tide is there, we will have wetlands as long as we're not in the way. And the last thing we need to have is the community. Not just the plant and animal community, but the human community. We're part of the ecosystem too. The old days of the Nature Conservancy, our mission was not in so many words, but it was essentially protect nature from people. And that's not the case anymore. I think we've come a long way to recognize that that's not a sustainable model. And what we need to do is have a community where the people and nature both can thrive. And the only way that either one is going to go on long into the future, especially in our changing world, is if we learn to work with people together. These are just some statistics from the National Climate Assessment about how important the coastal zone is to our economy. So it's a disproportionate, it's only about 20% of the land area, depending on how you classify a coastal zone, but it's more like 40 or 50% of our economy. The coastal states are only 60% of our land area, but 80% of our economy. So this is super important. Even if you're in Nebraska, the coastal zone is important to you because it's funding our government. And the other thing about all of these climate impacts, especially flooding, so on Long Island we know we're a little tight on space. We have a lot of people here, and there are a lot of use conflicts and fights over who can live where, how, when, where's the room for the nature. And as sea level rises and squeezes us, these kind of conflicts are only going to get worse. And the disparity between the haves and have-nots, the people who can afford to rebuild their houses, the people who can't, are going to get worse and worse and worse. So we need to start thinking about this now, before we're in crisis mode, before we're having wars over all these things, and get ready to figure out a coastal zone where everyone can coexist. So one strategy, one of many, is to use nature to protect people. And all across the world, forever, wetlands have been protecting the people behind them. You hear people talk about wetlands as a sponge, and they're absorbing floodwater, and that's true, technically. The volume of floodwater a wetland absorbs compared to the volume of water in the ocean is really quite small, as you might imagine. This is more relevant in a riverine system where the wetlands on the floodplain really are holding water. In the coastal zone, it's not so much that we're reducing the depth of flooding, but the important part is it's reducing the energy. So a restaurant owner, who actually you saw in a video yesterday, describes it like spilling a glass of wine across a marble table versus spilling a glass of wine across a felt pool table. That liquid is going to travel a lot less distance on that fuzzy surface. It's the same thing on a wetland. This is a photo from Delaware looking out into the water during a storm. You have a lot of whitecaps and rough water. This is probably a little bit of a dock that's underwater. So the tide is high. You can't see the wetland, but right here where this red line is where the wetland starts. You can kind of see those real high spartinas right at the edge. And what you see is it didn't stop the water, of course, but it stopped a lot of that wave energy. So now the areas behind that wetland are somewhat protected from all the damaging wave energy and erosion that comes with a big storm. So wetlands are not only beautiful, they're not only important for our fish and our critters and our birds, but they're protecting people. And the same is true for sand dunes and even beaches. All of that stuff is absorbing the energy of the water and protecting whatever is behind it. So we need to stay out of its way and let it do its thing. The Nature Conservancy did a study after Hurricane Sandy to kind of quantify these benefits. As you probably all know, New Jersey has a lot of intact wetlands between it and the water. New York certainly has some, not nearly as many, especially around the city, but in New York and New Jersey after Hurricane Sandy, about $625 million in flood damages were prevented because of the wetlands that were there. So however much it costs to protect or even restore our wetlands, we need to be thinking about it in this kind of a context, how much it can protect the people, keep us safe, which is invaluable, as well as protect our property. I want to talk just briefly about nature versus nature-based solutions, because you do hear a lot about this. What we need to do is protect as much as we possibly can of the intact natural coastal areas. All of these things that do have room to move in the full tidal range and all of those things I just talked about, we need to keep them that way. If we have a property and we're building a new house, build it back as far as you can. Let the natural vegetation be there on the edge. So real nature is the priority. Some places that's not possible. Some coastal infrastructure has to be protected and has to be located where it is. When that's the case, then we look at a whole menu of options for protection or armoring or whatever you want to call it. And when we get to that stage, that's where we really need to think, okay, these are our goals. We think we have to keep the shoreline here for whatever reason that is. We're not able to allow it room to move. Then we think about how we can incorporate nature. I like to liken it to sort of low-fat Twinkies. It's not nature. It's not a kale salad, but it's better than nothing. It's not appropriate in all situations. You know, if you're right on the ocean, you have a ton of big waves and tremendous energy coming in. A living shoreline, as we call them, is not going to protect your property. But in a lot of lower energy systems, it's a great option. A great alternative to a bulkhead is actually planting a salt marsh, giving it a little space, letting that salt marsh absorb the energy instead of a concrete wall or a wooden wall. And the great thing about that is that you get all these other benefits from these nature-based solutions that you don't get from the hardened solutions. You get a healthier environment. You get some outdoor space. Oftentimes, if you do this work in a park, for example, then now it's public space. People can access the water. People can enjoy it. You have a healthier community because people are walking more because they can get outside more. Spending time near the water reduces stress. And it increases social ties in your community because people can interact with one another. So to get to this point where we don't create ourselves a concrete bathtub, you know, unfortunately, our system right now is built around lines on a map. We manage land and we plan for land use based on lines on a map as if they stay there as soon as we write them down. Now they're official, they won't move. The coast is moving and that paradigm doesn't work anymore. So we need to sort of rethink how that works, how we manage our land and especially how we manage our coast. And in order to make room for wetlands and dunes and beaches, give it all those things that make our community resilient, and keep the people thriving and not make all of our social problems worse, we need a plan for that. And we don't need a plan for that in 50 years, because it takes a long time to get to these things. So we need to start now. So this little animation you see here, I do take credit for putting this together with some free software, but the idea for it comes from the East Hampton Star. This is a plan that the Hamlet of Montauk is putting together, a retreat plan to help get those hotels that are at the edge. You can see this photo here. You all saw this yesterday. These are hotels in Montauk. They were in jeopardy. Everyone was a little nervous, but nobody really knew what to do. And then Hurricane Sandy came, and then everyone really got nervous. And then the Army Corps and a lot of money came in, and they decided to give it a try with something a little more hard. They put these sandbags, and it hasn't worked. And I want us all to learn a lesson from this. When you don't have a plan, sometimes you wind up no better off or even worse off than you were before. So we need to make a plan now while we're not in emergency mode, while not everyone is panicking, while people aren't in danger, so that the next time money comes around, we're ready and we can do the smart thing to make a resilient community. Incidentally, this Hamlet plan for Montauk has not gotten over the finish line yet, unfortunately. If any of you live here, I hope that you'll help the town make this happen. It's a controversial thing, and it's very scary. Change is scary. Everyone knows that. But if we want to ever have Montauk in the long term, we need to figure out a way to make room for that dynamic shoreline to do its thing. Here's another example. This is the Massac Peninsula, where the town of Brookhaven, with help from the Nature Conservancy and the county, some New York State funding, some federal funding, is working really hard in that marsh migration zone to get those properties protected, to get the homes where people do want out, and restore those wetlands. A tremendous amount of progress has been made there. But as anyone from the town will tell you, it's crazy expensive to do this. And it's not easy. And you have to do planning. And you have to have infrastructure. And you have to have bulldozers. And it's a lot of work. These guys are a little bit ahead of the game. Most of Long Island kind of thinks about it a little, but doesn't have a plan and isn't working on it yet. We need to kind of kick it into gear. And the message that I want to leave you with is we hear a lot from our communications professionals, who are great and helpful, that this is all bad news. Climate change is a lot of bad news. You have to put a more positive spin on it. Nobody likes to hear it. And I think we're all starting to worry a little bit. Have we done a too good job about that? Are we making it not sound as urgent as it really is? So this past fall, the IPCC, that's the Intergovernmental Panel on Climate Change, basically came out with a report that said, we've been aiming to keep global warming below 2 degrees because we think that's where catastrophe really sets in. And all of our goals are working towards that. As you all know, we here in America are not doing a great job contributing to those goals. But what they did was another assessment to say, well, how bad is it at 1.5 degrees, which incidentally, we're already up to a degree into that, 2 degrees now. So how bad is it at 1.5 degrees, which we think is coming in the 40s or 50s? And turns out it's pretty much almost as bad as 2 degrees. So this is super dire, super urgent, and everyone needs to work on it. And I just want to put in a plug. This is old now. This is a podcast. You can get it from the New York Times website or wherever you like to get your podcasts. But it explains this report about how urgent this problem is. And then it explains how reducing our carbon is the only solution, the only way to get there, how our world is built around economics and how we need an economic solution to the problem. So if you're interested in that, I highly recommend this. Put it on when you're driving somewhere for half an hour. It'll keep you entertained and sort of give you some ideas about what you can support politically to make some progress here. And with that, I will end.
We do have time for questions.
Yay, I win!
In the absence of any kind of federal progress, in the state of New York, we have legislation called the Climate and Community Protection Act, which could indeed help mitigate and reduce our carbon footprint. Any individual or organization who wants to learn more about this and wants to interested in get involved, please, come to the table and see me. I'd be happy to speak with you about it. I wish more organizations would learn about this legislation. This is an opportunity for New York State to be a role model and to truly mitigate this problem and reduce our carbon footprint. And again, please see me if you're interested in dialoguing about it. Thank you.
Hello, thank you for the great presentation. My question is, you mentioned about marsh migration. How quickly can the marsh regrow, and can it keep up with the rising tide
So that's a
over
really
the
good
years?
question. Sometimes it can be very fast. It depends on the circumstances. We know that there will be a limit to it, and unfortunately, it's not a simple answer. Two things help a marsh grow and move: sediment, inorganic stuff, and then the root mass, the organic stuff that builds up the marsh. And depending on how big the tide is and the relative importance of the organic versus the inorganic in building up the marsh, when those controls are different, its speed and ability to change is different. So, across the eastern seaboard, there's a wide range of tidal ranges and a wide range of kind of marsh configurations where In some cases, the sediment supply is more important. In some cases, the plants are more important. On Long Island, we're seeing that it's really having a hard time accreting, that's building vertically upward, even with our current sea level. And we think that's a combination of sediment starvation because we're bulkheading and dredging and all of that, and the nutrient problems that we have, all of our water quality problems, are actually impacting the plant's ability to build underground biomass, all of that root mass. Just like if you over-fertilize a house plant, it grows really long and scraggly with no roots, same idea. So it's not investing in those roots because it doesn't need to because it's got so many nutrients. So the combination of those two things is making it really impossible for the marsh to build vertically. So its only hope is to migrate inland. And really the limiting factor there in most developed places is the stuff that's in the way. It's not so much its ability, a year or two, a lot of places on the south shore of Long Island, people are mowing marsh grass in their lawn because they're so close to it. It will come in very quickly. And because of the salt, it will outcompete most things pretty fast. But it's really the thing that's going to limit it on Long Island is us being in the way and messing with all those natural processes.
Thank you.
I'm sure we're not quite there yet in terms of the political will for this, but I'm just curious what your opinion is about things like subsidies or incentives, that can be leveraged in order to help finance some of these moves. And also, what, if any, role do the insurance companies play in this as well? It seems like they have a lot to win or lose, or are they just trying to take a hands-off position?
Yeah, so there's a complicated answer to all of what you just said. So yes, subsidies, government funding, private funding. If you think of, I showed you 150,000 homes chronically flooded, that's just New York State, and that's just with a pretty mediocre sea level rise projection. This is happening all around the edges of the country, and actually the entire interior of the country too, all around rivers. So the scale of the problem is such that there's no one solution. We actually need to do them all. And then the insurance question is a really interesting one. The private insurance industry has had this figured out for ages. That's why you can't get flood insurance from your homeowner's insurance company. They know better. It's just a losing proposition. So it's federally subsidized. And right now, federal flood insurance rates don't reflect the actual risk. That has to change at some point. The money is not infinite. So I think, to me, because we want a resilient system, including people who are thriving and not just nature, we don't want to wait until people are financially forced out. We want to come up with a plan and a place for people to go so they can stay in their community. They don't have to get their kids out of school. They don't have to move far away from their job. Essentially prevent all the pain and suffering that will come. The water's coming, like it or not. We'll get out of the way eventually, but we don't want to be forced out because that will be miserable. We want to kind of get ahead of it and make a plan so that we can adapt and not ruin everybody's lives in the process.
And could you say the name of the podcast again that you recommend?
Yeah, let me just, there. I don't know if you can see up there, but if you just Google a new climate tipping point and New York Times, you'll definitely find it.
Allison, awesome presentation. Thank you. My question is Fire Island. Now, it's a barrier island. It protects the South Shore from that wave energy. What's the short term for the health or protection of Fire Island? Overwash, saltwater intrusion, the shellfish industry, sea level rise for the South Shore. What is Fire Island looking like?
Yeah, that's a hard one. Fire Island is a tough spot. I don't know if you saw when I showed the map of the sea level rise projections for Suffolk County. It's underwater, pretty much. And the fact is, Fire Island is a great example, but it's not the only place this is happening. Before the ocean comes up, the groundwater comes up, and especially on the South Shore and on the barrier islands, where the slope of the land is really shallow, the groundwater flooding is really what's going to start forcing people to make decisions about where and how they live, even before the ocean gets you. So on Fire Island, that's already happening, and I think people are starting to recognize you can build walls to keep the ocean out. You cannot build walls to keep out the water that's coming up underneath you. So there are only so many options. The other thing about Fire Island is A barrier island is also a naturally very resilient system. It will move around. It might go to many islands and then reform and then go to an archipelago again over time. And what it would do, Fire Island, if it was just a sandy barrier island, is it would migrate actually toward the mainland as sea level rose. It would overwash, breaches would form and close, and put a whole bunch of sand on the backside of the island while the ocean side was eroding. And you would always have something, maybe not always, but for a long time, you would have something, and it would be slowly migrating toward the mainland. But it's not just a sandy barrier island. We have communities there. We have infrastructure there. We have a national park. We have all kinds of stuff that we want to protect. So we're not letting it do all those things. It's hard to say, really, what will happen to it under those circumstances. In our desire to keep it exactly where it is today, because that's the way we like it on Fire Island, we might kind of jeopardize its long-term ability to be resilient and stay there forever. Unfortunately, we're kind of in an experiment to see what happens there. But it is important to note that that barrier island, more than the wetlands or anything else, is the thing breaking that energy, protecting the South Shore of Long Island from the force of the ocean. That's the reason that we've been able to build so densely along the South Shore and right up to the edge. And if we don't allow Fire Island to stay Fire Island forever, we're really jeopardizing the entire South Shore, and it's important to remember that.
Okay, we are out of time. Allison, you'll be around
I will.
for questions, so thank
Thank
you.
you.